Systematic nomenclature of inorganic compounds. We're going to name inorganic compounds. We'll first look at binary compounds. Binary ionic compounds have a metal and a nonmetal. The metal is named first, just as the element. The nonmetal is named last by adding the suffix IDE to the nonmetal stem. Here are the nonmetal stems. It's not really necessary that you memorize these. It's just the first part of the non-metallic element's name. So let's look at a couple examples of some binary ionic compounds. This is a binary ionic compound. It's got a metal with a nonmetal. We name the metal first. Just the metal name, potassium. Br, we're going to use the stem for Br, which is brome, and then the suffix is IDE. If I give you the name like sodium hydride, and you ask to give me the formula, I'm just going to put the symbols together. Sodium is Na, hydride is H. We do need to balance charges, so we go back to the rules for oxidation states. Sodium is a +1. Hydrogen, when it's with a metal, is a -1, so those balance each other out. Calcium chloride, again, if I give you the name and you ask to give me the formula, you need to balance charges. Calcium chloride would have Ca, chloride is just Cl. Calcium would be a +2 always, and chloride, when it's with a metal, is -1 in a binary. So this would be CaCl2 would be the balanced formula for that binary ionic compound. Now some metals form 2 or more binary ionic compounds with the same nonmetal. So these metals have more than one oxidation state, and we have to indicate the oxidation state with Roman numerals. For example, copper is one of those metals that can exhibit multiple oxidation states. So Cu2O is a possible compound for copper, but so is CuO. Now oxygen is a -2, 99.9% of the time. So in the first case, copper has to be a +1. And so this would be called copper. We have to indicate the charge of copper with a Roman numeral. So we'll put a 1, and then oxide. In the second example, copper would be a +2 because oxygen is a -2, so we need to say copper, Roman numeral 2, oxide. So if you have one of these metals with Roman numerals, I'll give you one more, iron 2 chloride. The Roman numerals just indicate the charge. So iron 2 chloride means iron is a +2 because it can also be a +3, and then chloride is Cl, and that's a -1, so that would be FeCl2 for that balanced compound. Second type of binary compounds are binary covalent compounds. These are 2 nonmetals put together. The first element is named by giving just the name of the element. The second element, we're going to add that IDE suffix again. The only difference is if it's a covalent compound, we have to use prefixes to indicate the number of atoms of each element in a molecule. Now the prefixes, I'll give you 1 through 12 here, mono through dodeca. So if you have 2 nonmetals, let's go through some examples. You have SO2. That's a covalent compound, 2 nonmetals. We need to use prefixes to indicate the number of atoms. Now there's 1 sulfur, but I can omit mono if it's the first element. So I can just say sulfur. Since there's 2 oxygen, I'm going to say di, nonmetal stem, IDE, sulfur dioxide. So I can omit mono for the first element. It would have been acceptable had you put mono sulfur dioxide. Either one's okay. CO. I can omit mono for the first one, so I can just say carbon. However, I have to include mono for the second one if there's just one. And so it's carbon, there's just 1 oxygen, so that's monoxide. If I give you the words dichlorine, heptoxide. With these binary covalents, you don't have to worry about charges because I'm telling you how many atoms there are. Dichlorine means there are 2 Cl's. Heptoxide means there are 7 oxygens. So it's Cl2O7. You do not have to worry about charges with the binary covalents because I'm giving you the prefixes. Third type of binary are binary acids. These are a special type of binary covalent compound that contains hydrogen, and you can obtain hydrogen ions from this compound. They're named by giving the prefix hydro followed by the stem of the nonmetal and then ic acid. So I'll go through a couple examples of some binary acids. HCl, prefix would be hydro, nonmetal stem is chlor, and then ic acid. Let's do hydrosulfuric acid. It's got hydrogen and it has sulfur, and just like with the binary ionic, we have to do charges. Hydrogen is a +1 when it's with a nonmetal. Sulfur is in group 6, so that means it's -2. So hydrosulfuric acid would be H2S when we cross the charges.